Hi fellow enthusiasts, welcome to my channel. Let's go into today's video and we're gonna come back at the end to wrap it up. In this episode, we'll be looking at this RF transmitter and RF receiver modules. The transmitter is this one here, and the receiver is right here. There are three versions of this. There is the 315 megahertz, the 330 megahertz, and the 433 megahertz versions. So it depends on what you buy, but these modules can be used to control remote objects. Now, here's the proof of concept here. We have the transmitter with a single button connected to it, and we have the receiver here with an LED and a capacitor. Now, how this functions here is when I press this button on the transmit side, the VCC is connected to the data line, and that sends a positive pulse to the receiver, which is translated by the LED as an on state. So when I press it, it flashes one time. Now, there's no code involved here. This is pure hardwiring. Pure hardwiring, no codes involved. So when I press it, the receiver blinks. The Arduino you see here is just providing power supply to the receive side. The transmit side is receiving power from a USB connection. There's a positive and ground going into the transmitter, and then this button here. Very simple design here. Now, again, this is the introduction to the series, because later on in the series, we will be programming an AT-Tiny 85 as an encoder on the transmit side, and then programming another one also as a decoder on the receive side. Basically, the way this system is, if I power up another receiver, it will receive the same signal from the transmitter. So there's really no distinction between the transmitter and the receiver. I can use any other receiver in this system and it will work exactly the same. I don't have to use the pair. So this pair here came together. I brought them together, and the other pair came together. But if I pull the transmitter, for instance, and replace it with another transmitter, so I'm going to keep this here and remove this and replace it with another transmitter. It should work basically the same way. Doesn't matter. So there's no pairing happening here. Now what we're going to do with the microcontroller, so I'll just keep the pairs together just for the sake of it. But really there's no pairing involved. Let me make sure I have it connected properly. Right. Now, you might be wondering why we have a capacitor very close to the diode. The reason being, if I remove this capacitor, the output is almost always on because of the flickers coming from the receiver. So I'm going to put this capacitor one more time to shut it off. And then there's also another resistor that is also shunted across the capacitor. And the combination of these two, functioning as an RC network, the capacitor is discharged by the resistor, so it doesn't stay fully charged. So we did that to stop the flickering, so we can just notice when it blinks because we have pressed a button. Now, when we program the microcontroller, those will be taken care of. The microcontroller will detect certain frequencies or certain signals from the transmitter and translate that to the receiver. Now, you remember this microcontroller from our radio. When we programmed the radio, we were able to use one input-output pin to control channel up, channel down, volume up, volume down. We are going to replicate the same logic and use one input-output pin to control multiple signals or multiple buttons here. And then on the receive side, we can use digital logic to have just few outputs, and then use the LEDs. We can use 3 or 4 LEDs to indicate what button has been pressed from the transmit side. The reason for that is the microcontroller has about 5 or 6 usable input-output pins. So that will be 0, 1, 2, 3, 4, and 5, which is the reset pin. So we're not going to use the reset pin. Then pin 4 is the ground, and pin 8 is the VCC. So we're going to try to avoid using the reset pin. So that gives us practically about 5 usable pins. So 0, 1, 2, 3, and 4. So that's 5. So we use from 0 to 4, that is 5. So we can use 3 of them, maybe from 0 to 3, and have 3 LEDs there, and use digital logic. So it's going to be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, and so on and so forth, to indicate which button has been pressed. The limit is the storage space and the variables you can put on this microcontroller. Otherwise, the limit is your imagination. This is the beginning of the series. In the subsequent parts in this series, we'll be showing how we design encoding and decoding. All right. Thanks for sticking around to the end. That'll be it from us today. Please, if you have not subscribed, do so right now. And don't forget to like and share this video. Until we come your way again with more contents, stay enthused.